Hello everyone, welcome to our video tutorial on IT Professional Elective 2, which is Data Scalability and Analytics. So in this video, we will discuss about the basic of standard deviation and variance. So as connected to the subject Data Scalability and Analytics, of course, we have to learn the basic of statistic for about standard deviation and variance. Okay, so let's begin. So what is standard deviation? So standard deviation is a measure of how spread out numbers are. Okay, so for example, we want to know how far the distance of one location or one an item to another item, and then the distance from that item to another item or another thing. Okay, so it is a measurement uh, of spread out of those particular items. Okay, so the symbol is a Greek letter sigma. So this is the symbol in statistics. So the formula in computing the standard deviation is actually the square root of variance. Okay. So if you ask, what is the variance? Okay. So actually, before we compute the standard deviation, this is the most important requirement to compute the variance. Okay. So the variance is defined as the average of the square differences from the mean. Okay. So we have another math computation here. Mean is actually is equivalent to average. Okay, so the square differences from the mean, which is actually a variance. Okay, so these are the steps to calculate the variance. One is work out the mean. So we have to get the average of the numbers. Then for each number, subtract the mean and square the result. Okay, so after we get the average, we will subtract the mean and square it. Okay, square it, and which is actually the square difference. Then work out the average, those squared differences, those that now we can get the variance. So that is the steps to get the variance. So let's take an example. So we have here a an example. This example is about the height of dogs, and we will determine the height. We will measure the height. It's already there later. The height of the 5 dogs. So the first picture here, in the picture there, the first dog is somewhat a very tall dog compared to others. Okay, and it measures based on its shoulder. So the height of dog there. So the height of dog in the second dog is measures based on the in the shoulder, and so on and so forth. So um, measuring the heights of dogs in millimeters in this example. So the heights at the shoulder, okay, are from first dog 600 millimeter. The second dog is around, it is actually 470 millimeter, 170 millimeter, 430, and 300 millimeter. Okay, so now once we have now those heights, we will now get the mean, and of course we can get the variance and the standard deviation. So from 600, so from the heights, all of heights, we have to total it. So 600 plus 470 plus 170 plus 430 plus 300 of all heights of dogs. We divided how many items, which is actually 5 dogs. So 1970, okay, total heights divided by 5, which is actually 394. That is the average or the mean of all heights of dogs. Okay, so we have now the mean or the average. So the next step is we will now plot now the average of heights of dogs. So it's actually from 0 to 100, 400, 600. You will notice that based from the computation, 394 is just below 400 here. Okay. Okay. At the green horizontal line, green is actually 394 millimeter as the average size, average height of a dog. Okay. So now let us now compute the variance. Okay. So to compute the variance, we have to determine the difference from height and the computed average of dog, height of dog. Okay. So from 600 millimeter less, okay, less the height of dog is 600 millimeter, and the average is 394, which actually 206. So that is the difference. Another is 400. The second dog is the height is 470, and then minus or less of the next height of dog, which actually okay, the next height 470 minus the average computed mean, so that is 76. Okay, so if we use calculator, so for example 600, that is the height of the first dog, minus 394 computed average, it's actually 206. So the next dog is, look at the difference from height to the computed average is, so the height of dog is 470 less or minus 394. So we have here 76. So the computed difference here from height to the average is 76. Okay, so that's it. So the third dog is negative 224, the second dog is 36, and then the fifth dog is, the fourth dog is 36, and the fifth dog is, its difference from height to the computer is 94. Okay, so we got now the difference. So to calculate the variance, so of course we have to get the difference, square it, then average the result. So simply 206 square plus 76 square plus negative 224 square, it will make a positive, plus 36 square plus negative 94 square, so all positive, 42,436 plus 5,776 plus 50,176 plus 1,296 plus 8,836 divided by 5, with a total difference of 108,520 divided by 5, which gives us a variance of 21,000. Okay, a variance of 21,704. Okay, so that is the variance, 21,704. Now we can now get the standard deviation. So the variance is 21,704, and the standard deviation is just the square root of the variance. So the standard deviation is the square root of 21,704, which actually 147.32. It's a nearest millimeter. So 147. Okay, 147. Which, so the standard deviation is 147. Now we could now, once we have now this value, standard deviation, we could now plot here from the picture in the height of dogs with regard of how it is spread its numbers, okay, regarding its height. 147. So we have here, based from the average mean of height, we have to make it plus 147 here, okay. So we have another minus, okay, 147 here, okay. So we could see now that the height of dog, we can determine it if it is a normal height or somewhat smaller height. So, and the good thing about standard deviation is that it is useful. Now we can show which heights are within what standard deviation, 147 millimeter of the mean. So, using the standard deviation, we have the standard way of knowing what is normal, okay, and what is extra large or extra small. So, as we can see in the picture here, normal height is actually the second dog, because it is under in the within the range of positive 147. So it is a normal height. And also in the fourth dog, it is a normal height because it is within the range of positive 147. And the first dog here, the Rottweiler, is somewhat extra tall. It is outside 147. Okay, and another is we have um, two uh, small dogs here, extra small dogs here. The other one is extra tall here, okay, extra large, and we have here extra small here, the third one and the fifth one, okay. So so we could now determine what is a normal in that height, a normal height, and the extra large height or extra tall height, and we could determine the dog which is, or we can identify the dog if it is uh, extra small height. Okay, so I think you understand about this standard deviation to determine the normal measurement of that spreading of, items or thing. So that's it for our video tutorial. I hope you learned something. You just put comment if you have question. So just to remind you that this tutorial are based actually from a website, mapisfun.com. Okay, it's regarding its content and its graphic. Okay, so thank you and goodbye.